All right. What was the question? You had a question?
Yeah, so first of all, I'm struggled at problem 60. I'm not sure how to do it.
Okay. Um, Question 60 in the homework.
Yeah. Yeah, and the homework.
All right. Let me actually pull up what question 60 is. All right. All right. Chapter 13.
Yes.
All right. Question 60. All right. So this is a question where you have to use Bernoulli's.
Yeah. Mm.
What page number was it?
Uh, I I think is. Hmm. Do you mean on the Google Drive?
Yeah. Well, like in the textbook.
Mm. On let
Oh,
me see. It's like 386 on Google Drive. I couldn't see the page number on the papers.
all right. I'm just trying to look because I have the textbook in front of me.
Oh yeah. You can just like see the table of contents and turn to page
Mm-hmm.
to the end of chapter 13.
Yep, I got it. Okay, so question 60. Okay, so they give us this setup, and they said that they want us to use figure 1332. What page is that? Oh, God, that's far back. All right. Basically, the way that you're supposed to do this is you're supposed to start with the whole Bernoulli's equation, uh,
Yeah.
and then you're supposed to actually combine it with the flow rate equation, the AV equals AV equation.
A like A1 V1 equals A2 A2.
Yes.
Okay.
Yeah. So if you look at diagram 32,
Mm-hmm.
um, where is it?
Mm-hmm.
Sorry, there's such a delay in the
Oh,
digital thing. All right.
okay.
So when you use Bernoulli's equation, you have the pressure term, the velocity term, and then the height term, right?
Yeah.
In the Venturi meter that they have for figure 1332, there is no height, so that those two height terms on both sides drop out. So you
Yeah.
end up with p plus 1/2 rho v squared equals p2 plus 1/2 rho v squared, right?
Yeah.
Yeah. So what you're then going to do is because of the flow rate equation, we have a relationship to take v2, let's say. Um, Actually, is that the one we're solving for?
Yeah.
Yeah, we have a way of taking v2 and rewriting it in terms of v1 and um, a1 and a2 with that flow rate equation.
Okay.
Does that make sense?
So
All right.
yeah. So
So let me present part of my screen. So it's that.
mm,
And then it would be that one. All right. So you see my screen?
let me. Oh yeah. Wait. Let me see. Yeah, I could see here. Let me try to make it bigger. Okay. Yeah.
All right. So like I said, when we use Bernoulli's, we end up with this setup after we
Yeah.
realize that the heights drop out, and then using the flow rate equation, we know this is true.
Yeah.
And because the equation that they want us to get to doesn't have a V2, that means what I want to do is use the flow rate equation, solve for V2 like that.
Yeah.
And then this entire term is going to get plugged into here.
Oh, yeah.
Yeah, so then from there, it's just moving things around. Like, for example, let me just give myself a little bit bigger space. So then, like, for example, I can multiply both sides by 2 to get the two P1, P2s right there. I can move these terms over, so I can move this term over to here, this term over to here, turn these into subtraction.
Yeah.
Pull out, factor out the 2, factor out the row, and then you can start to see how like it's going to end up looking like what they give us.
Yeah. Oh wait, I think I just got it. Yeah. So row. So you can switch. So it's gonna become row v1 square times a1 square over a2 square,
Yes.
and then minus row v1 square.
Yeah, and then you can pull out a row v1 squared from both
Mm,
terms. Like I said, move things around.
yeah.
Um, and you would use some algebraic, hand waviness essentially to get it to that setup. I will say that one of the things that's really nice about those types of questions is that you know kind of where the endpoint is, so you can almost
Yeah.
finagle your way that way.
Yeah.
Uh,
So
and then part B, yeah, part B is just plugging the numbers into that equation.
so measure the flow water main diameter. Okay, so pressure, what's the speed? Pressure difference. Um, so is it looking for? Uh,
Now, one of the interesting things I'll say about this question is
yeah,
that if you actually left it in sort of basically if you didn't solve it the way they did, so I think if you solve this, you get something that looks like let's call it. Let me actually change my handwriting. So two delta p um, divided by rho, then it would be a1 squared over a2 squared minus 1. I think you end up getting something that looks like this. But one of the interesting things I was is this. All right. So what I was saying is that if you get to this point, one of the interesting things is that because of the equation being for area for the cross sectional area being
yeah,
pi r squared, which can actually be rewritten as uh, pi d squared over 4, right?
yeah,
Well, you can actually rewrite this as rho d1 squared over d2 squared because the pi 4 is going to end up getting dropped out in top and bottom.
mm,
It's just it's one of those nice things that if you kind of manipulate the equation, it makes it a lot easier because on the other side, if you did want to, if you were going to use the equation that they had given in part A, you kind of have to like calculate what A1 and A2 are. So it
mm,
makes it a little bit more extra legwork, especially with the fact that there's that the difference in units can get it a little confusing. So you might be unsure about whether or not you should convert or not. Um, if you do it that way, then you realize that the units and the diameters just cross out, so they don't matter, and it's only the pressure that has to be converted properly.
Uh, okay, wait, let me. So we have to. So we have to use the pressure difference, which they had given is like.
18, 18 millimeters.
Do we have to switch that to Pascal?
Um, yeah. Just, you need to convert to pascals. Um, but
Okay.
but thing is, like with the units for the area, you probably the way the original equation's written, you probably should convert just to be on the safe side. But if you rewrite it like I did, then you'll find that you don't actually need to convert the diameters, and it saves you a little bit of time and effort, since like I said, you don't have to calculate the cross sectional area anymore.
Oh, oh, I see. Cause uh, like they are just gonna be. You just need to find it. Yeah, cause pi basically like pi r squared is pi half diameter.
Yeah.
Yeah.
Yeah, the going from a ratio of area is directly proportional to a ratio of the diameters.
Okay. So. Okay, so let's see. Difference in pressures.
Oh, actually, I think I made a mistake with my equation.
What
Um,
happened?
the area is being squared in both top and bottom, so that would mean
Oh,
that this is to the fourth.
is it D4?
Uh,
Oh yeah.
yeah, because I was just realizing that diameter. What I said, I said it, area was proportional to the diameter, but that's not true. It's proportional to diameter squared.
Hi,
Hi there.
can I just ask a quick question?
Of
Um,
course.
I I don't go to um like school here. I'm just taking this as a summer class. Um, and so I had some trouble like logging in last week and figuring out like Blackboard and all of the other things. So I ended up missing the first homework assignment. Is there any way that I could make that up?
The
Um,
homework assignments are actually all posted through Google Classroom.
yeah, I'm able to see them now.
Okay. Sure. I can give you a reprieve on the first homework.
Okay, great. Thanks. Should I submit like submit that like tonight?
Yes.
Okay,
Yes.
great. Thank you.
No problem.
Hi, Mr. Claw.
Yeah. What's up?
Oh, so I got around 0.2446 meters per second.
All right. 0.244. You said?
Yeah, kind of.
Yeah. Hmm.
Okay. There's another thing is can I ask about approximately how many questions are gonna be on the test?
Yeah. So well, okay. So there's going to be two 10-point questions on the test.
Like
One.
like
Yeah.
short
Short.
response.
Yeah. Free response type questions. One question is going to be from the statics chapter, and one's going to be from the fluids chapter. And for the most part, every exam is going to be like that, where you're going to have two questions, one from one chapter, one from another. The only exception is test two. That's only because we cover three chapters that section. Um,
Wait, I mean, there's not even gonna be a multiple choice question.
nope.
Just two. Oh, okay.
Yeah. But the free response, they all have multiple parts to it. So
Uh,
yeah, so it's going to be like a part A, a part B, a part C that you have to answer with the parts being split up. That's actually why I said it's 10 points. So it's two 10-point questions.
okay.
I would basically I mean, first off, there's a practice exam, right, that was
Yeah.
posted. If you look at practice exam 2, that has the format down. So you could
Um.
check out practice exam 2. That's going to be essentially my first test. Just look at the first two questions. That's test 1. So that's going to have exactly how it's written, style, all that stuff. Um, and then you can look at the answer key to see, what I'm looking for as far as answers go, as like the type of work that you do. And you'll notice that most of the questions should be done in like a few steps. Some of the static questions might be a little bit more involved, but for the most part, a lot of 2-point questions specifically are typically like write the equation that we have for it and then substitute numbers in.
I only found like a practice midterm.
That might only be a practice midterm. That might be on the Blackboard. Have you looked on Google Classroom?
Oh yeah, I'm looking at Google Classroom.
All right. So let me look at Google Classroom. So classwork, if you go to exam sections, so if you go practice midterm 1, there's
Oh,
practice
okay.
and then practice 2.
Oh, I see.
Yeah. Like I said, there was two versions. I don't know why I still have that first version up. Yeah, I don't know why. I think I might have the questions slightly different, but for the
Uh,
most part, the way I describe it is that I'm essentially taking like 5 of the questions from the homeworks and smushing them together into one question.
wait. So you mean the test is gonna be homework questions combined
Oh,
together?
no, not exactly homework questions, but more like there's a question in the homework that looks very similar to part A of question 1, and then there's a question in the
Uh,
homework that's going to look very similar to part B from homework from the homework. You know what I mean? So it's like I did that, and then style wise. So I'm the way I put it is that if you were able to answer the homeworks completely, you fully understand them. You didn't need to use an outside source, or at least if you did, you use that to figure out what was going on and to further understand it. Then the test shouldn't be difficult.
so the test is gonna be similar style to the homework questions,
Yeah,
right?
yeah,
Okay.
not like I just want to clarify because, like I said, some people misunderstand me when they say that, and they think it's going to look like, just one of the homework questions, but that's going to be like part A of a homework of the test. So like,
Yeah. Yeah, and for additionally, like after we test one chapter is done, like we're no longer gonna do another
yeah,
test cover that chapter, right?
yeah, we're not going back. We don't. It's not non-cumulative. So once we
Yeah.
get to after test 1, we won't really talk about statics and fluids. Though I would avoid completely disregarding it. So as I mentioned, this course is essentially split into 3 parts. The
Yeah.
first part is the mechanic junk section, where it's all the leftover stuff from Physics 125, all the
Yeah.
other mechanic stuff that wasn't covered there, that we cover here, fluid, statics, waves, and harmonics, and none of them are related. None of them are really connected with each other.
Yeah.
But when we get to the thermo section, uh, because there are 4 chapters in the thermodynamics section, and we're going to end up
Yeah.
having 2 tests, there is connection between them. So some of
Okay.
the equations that we use in test 3, which is going to be part 1 of thermodynamics, uh, are probably going to be reused in part 2 of the thermodynamics test 4.
Okay.
And same thing applies for the third section, which is the wave and optics section, because again, we end up with 4 chapters where there's going to be some rehash of some of the information. So some equations from part 1 of the final is going to reappear in part 2 of the final.
Okay.
Yeah, so while it's fine for test 1 and test 2 to essentially completely ignore everything that came before it, and
Yeah.
then when we get to test 3, basically again completely ignore everything preceding it. You want to make sure that going into the next part, you kind of don't ignore that information.
Oh, wait, do you mean like even the midterm is not cumulative?
Yeah,
Oh,
none
even
none of my exams are cumulative. The final, for the most part, like I said, is essentially just a slightly longer test focusing on the third part of the topic, third part of this course.
I see it shows like 34 to 35.
Yeah, because like I said, it's slightly longer. So for the other test, it was there's like each test. So each test is going to be two 10-point questions. So like I said, it's designed to be 40 minutes long. For the final, you're going to end up having, I guess I should have phrased it as two 15-point questions. So it's going to be out of
Oh,
30 points rather than 20.
oh,
Or actually, so I do this weird thing because my grading is still set up assuming that test 1 and test 2 are one single test, or so is like one midterm. So the 2 parts of the final, it's the finals out of 60 points, while the midterms are out of 40 points in total. So that's
yeah,
why it's a little bit more weighted for the final, but it's also not that much weighted. If you notice, it's only 35 versus 25.
yeah,
Um, this is actually something important because there were a few people in previous years. There's always that one person that doesn't understand it. That the final is not designed in this class to be make it or break it. I know there are some classes that are like that where you could fail every test before it, but if you pass the final, then you pass for the year, or you could be doing really well on all your tests, and all of a sudden you flop on that final, and all of a
yeah,
sudden your entire grade is just wiped. That's
yeah,
not this. For the most part, if you got a C and a C on the first 2 tests, and then you fail the final, yeah, it's gonna hurt your grade, but it's not gonna make you fail for the year. It's gonna, well, not with an F. You know,
yeah, this is much better than the AP physics in high school, which you need to, all the things are depending on your AP exam.
yeah. So I mean, okay, so if you took AP, then the style of the questions are very similar to the AP free response questions.
Yeah,
That's essentially what it is. Like I said, I'm an AP teacher, so I model what I know. Um,
wait,
I
you also teach AP?
Yeah, I teach AP over at high school.
Wow, that's really good to hear.
Yeah, so I do try to keep that similar style, though. I guess this would be more equivalent to APC rather than AP1,
Yeah,
or APC, APB,
yeah,
that style. But yeah, I just wanted to mention that because, like I said, I had a few people kind of mentioning like, how's that I can get an A on the an A on the final and my grade barely goes up, and I have to try to explain that, because
yeah.
this is like it's not worth that much more than a regular test.
Yeah. Yeah. Okay. Thank you very much for your information, Mr. Claw.
No problem.
Yeah. By the way, just by the end, may I? Oh, it's never mind. May I know what high school are you teaching AP? Just curious.
William Floyd,
Okay, never
current.
mind.
Yeah.
Maybe I didn't hear about it. I'm in New York City.
Oh yeah, no. I'm on the island.
Oh, okay.
Actually, I don't know if I mentioned this. Did you guys know that the exams are curved?
Oh, wow. Okay, that's also great news to hear.
Yeah, it's curved, but I should point out, similar to the AP, it's typically curved based off of how the class does.
Yeah.
So, if uh so yeah, like, you know, where you stand will be based off of how much better you do than everyone else, essentially. So, like someone who's getting an A, that's typically because they're getting the highest results compared to everyone else.
Okay. Yeah. Thank you. You're a really nice teacher.
No problem.
Okay. Yeah. That's basically all right now. I will come back later if I have any other questions.
Of course.
Okay. Bye, Mr. Klaus. See you
See you later. Does anyone else
later.
have any other questions?
Hey.
Of course.
Yeah, I just downloaded the PDF of the textbook that
Hmm.
was linked to the Google Classrooms, and on my version, the bottom of every page is cut off a little bit.
Hmm.
So I'm not sure if I'm like the only one
Yeah,
having a problem or not.
yeah. I'm seeing the same thing. It's cut off. Are there any questions specifically that seem to that it's affecting?
I'm not sure. Yeah, I didn't see any so far, but I was just wondering if that was going to be
I don't know.
mentioned in the PDF. Okay.
It could. And if that's the case, then I can take out my version, my like physical copy of the textbook, and just send like upload a quick picture of it. Um, I
Okay.
don't.
Thanks.
Yeah, yeah, because I'm looking at it. Chapter 13, question 75 is completely cut off. I just don't know how long that question was, and so
Mhm.
is question. Yeah, so yeah, there are going to be some questions. There are some questions that are definitely cut off, and you could be missing most of the information. So if it is an issue, and one of the homework questions seems to be one of those, let me know.
Okay. Thank you. I just wanted to make sure I was using the right version of the textbook. So thanks.
No problem. Hi, do you have a question?
Hello, Professor. Can I ask a question about homework?
Of course. Which homework?
Um, it's chapter 14.
All right. Let me bear with me while I scroll down to question 14. Um, I'm using the digital textbook right now.
Yeah, me too.
Um, it's just being really delayed. All right. Question. Which question?
50, 56.
56. All right. So the damping one. All right. I will point out one thing is that um, I think the how many questions were in the damping section? It's probably what, one or two.
1.
One, yeah. So this isn't going to be a huge part of the test. There might be like a single part of the test question that's based off of this might deal with damping, but most of the questions will be focused on the other parts. But what exactly was the question?
I'm look at part C, and I think he wants me to find phi. And I think I need to know amplitude to find phi, but I don't see how I can get amplitude.
I don't know if you need it. Yeah, I don't think you need 5 for that. Let me just double check. Because you're right with the, well, I think they might have given you the amplitude.
Is it? I don't see it.
Yeah. The amplitude is that. Oh, wait a minute. All right. All right. So what you're supposed to do? Let me go back. Like I said, it's kind of the reason why um, didn't want to do it too much. All right. So if you go to uh, equation 14-60, it's right before the question section.
Okay, just a second. Okay, I found it.
Okay. So this is going to be we're going to use this equation. We're going to set t equal to 0 in this case. Um, and then we're essentially going to actually, yeah. All right, sorry. So they said that at t equals 0, x equals 0. So the equation that they have is not going to be cosine. So I misread what it said, and it wasn't making much sense. I thought they said at t equals 0, x was equal to 0.12. So I just scrolled back. So they say t equals 0, x equals 0. The only trig function that happens for it is um, for sine, right?
Yes.
So what we can do is rewrite that equation so that it was x equals a e to the, what was it again? Negative gamma t
Yes.
sine omega t. And then what we can do is, since we know at t equals 1 second, jeez, I cannot remember anything. At t equals 1 second, x is 0.12. Plug in what you have for omega, plug in what you have for gamma, and then you can use that to solve for the amplitude. Oh.
Okay, so the amplitude is the same for the first situation and the second situation. The situation where it says that t equals 1 second and x equals 0.12
Yeah,
maybe.
so the amplitude is actually like the amplitude in this equation is actually referring to the initial amplitude, like the maximum displacement. The what we would consider the amplitude, like the height of each crest, where every time it kind of goes up, it goes down a little bit more. That's actually this entire term. So a e to the negative omega t is actually what's happening to the amplitude, and the e to negative omega t is decreasing it over time. But a still remains the same all throughout the entire equation or entire scenario. Does
Okay,
that kind of make
so
sense?
yeah, what's the difference between the first situation and the second one?
The 0 and the 1 second.
Yeah,
There's
yeah.
uh, those aren't those are considered initial conditions. They're only meant to actually figure out what A is. So first the first they're both referring to the same scenario. I should point that out, that it's not like it's, oh, here's one example and then here's another example. Like, it's referring to the same thing, but they're giving you conditions so that you can figure out certain values. Like I said, that first statement that they said that x equals 0, then sorry, when t equals 0, x equals 0, is basically telling us a that we're using sine, not cosine, since it has to start at 0 rather than starting at a number, and b, it's telling us that there's no phase shift.
Okay, that was clear. Thank you.
Yeah, like it. So that's actually what the initial condition actually is meant strictly for that. So whenever they tell you, oh, x equals something or anything equals something at t equals 0, it's usually meant to identify what trig function we're using and whether or not there's a phase shift there. Because if we have an amplitude being, if like we know that our amplitude ends up being 5 meters, but the initial position is 3 meters, then what we can say is, well, we know that there has to be a phase shift because the only two trig functions we have, sine and cosine, would start either at 0 or 5. So since I'm starting at neither, I'm starting at something in between, there has to be some sort of phase shift kind of bringing me between there.
Yeah, I got that. Can I ask you another question about also in chapter 14?
Sure.
It's problem 64.
All right, problem 64. Oh, of course, resonance. All right. All right. So they want us to use the equation 1423. Let me go back. Slowly figure out where 1423 is. All right. So they want us to differentiate this equation with respect to. Do they say specifically?
No.
Let me just reread the question. All right. So we're solving for omega. So we're going to differentiate the amplitude with respect to the omega, because that's actually the variable term in the equation.
Okay.
So let me. What was the equation? Had I already forgot it? It was omega equals square root omega naught minus b squared over 2m. All right, and the equation. Sorry, I do not remember these equations off the top of my head. All right, where's the equation? All right, and then the equation is a naught equals f over m square root omega squared minus omega naught squared squared minus that, right? That's the equation? Oh no, it's plus. And the m squared too. Plus and all right. Yeah, so what we have to do is we have to try to rewrite this equation and take the partial derivative of it with respect to omega. The omega's in the bottom, so you kind of have to fool around with it a bit and use what is it's the chain rule, right? That's the phrase in math. So typically, because the omega term is on the bottom, you kind of want to rewrite it so that it's more in the numerator. And this makes it so that you can do the chain rule a lot easier. Oh boy, I just realized it. I think you have to do two chain rules. Um, but yeah, you just take the derivative of this with respect to omega. Uh, and since they want to find where what was the phrasing? Where the maximum peaks are. Is it maximum or minimums? Oh, just show that it peaks at that. Okay. So what you would do is um, you need to find where the peak is, which is when the derivative is equal to 0. So you take this, set it equal to 0. Does that make sense?
Yes.
Do you have any other questions?
No. Thank you so much.
No problem. Hey, do you have a question?
Hello. I don't actually have any questions either. I was just, well, maybe a few. Not about physics actually. I was just wondering, this is the first time I've actually been to a meeting, and if I had like deciphered everything correctly, um we don't ever have to come to these.
No, especially since I'm going to try to post these. I'm actually recording these right now.
Okay.
I'm going to try to post them online so that you can see it and like see what other people have asked.
Mhm.
So I guess you could say that you really only have to come on here to if you have a question.
Yeah. Okay. Sounds good. Just wanted to make sure that I felt like I'm not from Stony Brook, so I was like getting on the new website trying to figure everything out, and I just want to make sure I didn't miss anything.
Yeah,
Uh,
no, that's pretty fine. For the most part, the only things that you have to make sure you do, and you especially do on time,
yeah.
are the tests and homeworks. Those
Yeah.
are really the only things that are necessary. Everything else, ed puzzles, just like with my class, you don't actually have to do them. It's all um, recommended. But any attendance that I take is
You cut out.
strictly
Yeah, my
for
class.
legal issues.
Okay. All right. Sounds good. Yeah, I just want to make sure I wasn't missing anything. So I appreciate that.
All right, no problem.
Thank you. Have a good day.
You too. Hey, how's it going? You have a question?
Hey, yeah, it's a question on problem 4 of homework 2. And the question asks to state. Oh, okay. Is that I might be reading this wrong, but is that a reference to another problem, or when it says state your mass, would it be like the mass of myself?
Let me see. Which question is this? You said it was chapter. Oh, that's not chapter 2.
Yeah, it's the problems after chapter 13, question 4.
All right. Oops. Sorry. I'm just trying to scroll somehow. Okay. Let's try a little bit more. Okay, so what question was that again?
Question 4. Is
Yeah.
it?
Yeah,
the
it's state
question-
your specific mass.
Oh, okay. Thanks.
No problem.
Hi, Professor.
Hi, how's it going?
Good. How are you? I have a few questions about the exam. Um, so first, like, do we have to go on this Google Meet to get proctor or anything?
No.
Okay, so we just do it on our own.
Yeah.
Okay, and when will we have access to the exam? Is it at 6 or at 7?
It's gonna it's gonna open up at 6.
Okay.
And it should be if it should be visible. If it's not visible, let me know. But it's gonna
Okay.
open up at 6,
Mhm.
and then you have 1 hour to complete it.
Mhm.
You can start it at any time between 6 and 8:15.
Okay.
However, I recommend that you start it before 7:15 because I can't guarantee that if you start
Mhm.
after 7:15, it
Mhm.
might auto submit before the hour.
Oh, okay, I see. Okay. And we will be able to find it, like, it will be uploaded on the submission page in Google Classroom?
I think so.
Okay. And
Either that or I mean, it's posted in the assignment section.
okay, sounds good. Mhm. And so I think my final question would be like, do we email you our work or do we submit it through Google Classroom? Because I think in the
You're
video
gonna
you said. Mhm.
submit it through Google Classroom.
Okay, sounds good. And so the format should just be like PDF or JPEG or anything like that.
Yeah, I mean PDF is probably best, but it
Hmm.
doesn't really matter.
Okay, thank you so much.
No problem. Hey, what's up?
Yeah, I just had a question on the homework for
Of
homework
course.
number on the last problem,
All right.
question 60 on chapter 13, I think. Yeah.
Okay. Sorry, I'm just trying to figure out where it is in the virtual textbook.
Hmm. I think it's page 386. If you have the same one, I'm not sure.
386. All right. What question?
60. Last question on the homework.
Question 60.
Yeah, 60, 60.
Okay. Yeah. What's up?
Yeah, I was trying to solve it, right? I plan on using the equation of continuity. I'm not sure if I had the right step, but I did like A1 V1 is equal to A2 V2, and then I also tried to use the mass flow rate is equal to the change in mass of the change in time, and I was able to get that row one A1 B1 is equal to row two A2 B2, but like I don't really understand how that can change into the equation I'm supposed to prove.
All right. So I think what you'd want to do instead
Mm-hmm.
is you want to use the combination of Bernoulli's with the flow rate equation, the AV equals AV1 to
Okay.
continuity. So so with Bernoulli's, so they specifically mention figure 1332,
Mm-hmm.
which is that horizontal Venturi tube. The reason
Yeah.
they specify that is because if you look at the Bernoulli's equation, there's three different terms. There's a
Mm-hmm.
pressure, a velocity term, and then a height-based term. The height-based term cancels out because it's a horizontal tube.
Wait 1 second. I thought Bernoulli's was just the 1/2 row V1 plus row G V1 is equal to the V2. Is that?
No, it's the pressure plus 1/2 rho v 1 squared plus rho g h 1 equals some constant. Bernoulli's is like the entire thing.
Oh wait, I'm
It
kind of confused. Wait.
it gets simplified in a variety of different ways,
Mm-hmm.
but Bernoulli's is referring to like the big equation with pressure as well. If you look back, page 382. It's
Yeah.
equation 13-8.
13. Page 382. You said?
Yeah,
Oh yeah, that's the one. Oh okay.
yeah. So you're going to use that, except the rho gy uh,
Mm-hmm.
on both sides get dropped out because it's a horizontal tube. So you only have the p and the rho v squared sections.
Oh, that makes more sense. Yeah, I didn't. Yeah, I didn't put in the P1 and P2.
Yeah. So
Oh
if
yeah.
if you combine that with the
Mm-hmm.
continuity equation, you get it
Yeah.
basically simplifies fairly quickly.
Mm-hmm. Yeah, it makes sense now. I got it. I also had one more question about the test on it's Wednesday, right? It's just on chapter 13 and 12. Is it the first half?
Yes. Yes. First
Got
two
it.
chapters.
And we get 1 hour for the test, or is it one
Yep.
1 hour?
1 hour.
Okay. And you're gonna post it at like 6, I'm assuming, and then you just send
Hmm.
it in at 7. Okay,
Yeah.
got it.
So it opens up at 6. Obviously, I'd want you to start it at 6, but I know
Yeah.
some people have some issues, so you can start it at any time during the actual class time,
Mm-hmm.
6:15. However, I recommend starting it before 7:15 because I
Yeah.
can't guarantee that the test won't auto submit while you're taking it.
Oh, we're taking the test on Blackboard.
Yeah, I
Oh,
mean
okay.
you're not submitting anything on Blackboard, but it's
Uh
just
huh.
that like you'll be looking at the test, and there's a chance that if you start at, let's say, 8 o'clock, that
Mm-hmm.
15 minutes in the test might auto submit because the 8:15 deadline pops up. That's
Oh yeah, I
why
got it. Uh
that's
huh.
why I recommend start it before 7:15 so you don't have to um, consider that.
And then we're supposed to hand in our work after we hand it in, right?
Yes, you have 15
Okay,
minutes to submit it through Google Classroom.
got it. I had one last question. I was looking at the question 56, the one before.
Hmm.
On part B, I didn't use P2. Like I just because I derived it in that V1 is equal to the square root of 2G times Y2 minus Y1. So I was confused if I was supposed to use the pressure too.
Say that one more time.
Because I was confused on why they gave me like I don't know if I messed up because I didn't use pressure 2 is equal to 0.85. I just used the second value they gave me.
Yeah. Let me just look at the because that should be another one where you use Bernoulli's.
Yeah, I used Bernoulli's for that one because the two pressures are equal to each other.
Oh, but they're not.
They're not.
No, they said that the pressure at the top is has a an additional pressure. That's actually where they said an external gauge pressure. So the pressure at the spigot or at the hole is being exposed to atmospheric pressure. The top is
Um,
being is exposed to atmospheric pressure plus the gauge pressure.
oh, okay. Oh, okay.
Yeah, honestly, that's actually going to be one of the more
Oh, yeah. I didn't
tricky.
read that. Yeah, I didn't read that correctly.
Yeah, it's going to be the trickier part about fluids is always having to remember whether or not you take into account atmospheric pressure or gauge pressure, and like the fact that gauge pressure is technically the difference in pressure rather than the actual pressure.
Oh, okay. So then, when I'm setting up the equation with Bernoulli, I would have to add like an extra pressure on the P2 side then.
Yes and no.
Oh.
So that's the case where both sides are going to have atmospheric pressure,
Hmm.
but one side is going to have P2 while the other one won't. So like if you write the equation, you'll have P0 plus a bunch of stuff
Yeah.
equals P0 plus P2 plus a bunch of stuff. So the P zeros will actually cancel out.
And P0 is the atmospheric pressure.
Yes.
Okay. Oh, that makes more sense. Okay, yeah. Yeah, that's it for me. I'm done with my
All
done with
right.
my questions.
All right. If you
Yeah.
have any other follow-up questions, please let me
Mhm.
know.
Yeah, for sure. Thank you so much. Appreciate the help.
No problem. Have a great day.
You too.